Lewis Cermaki Lewis frames themselves as a design-intensive architecture firm founded in 1997 by Paul Lewis, Mark Cermaki, and David J. Lewis, located in New York City. LTL Architects engages a diverse range of work, from large-scale academic and cultural buildings to interiors and speculative research projects. All of this work, they write, quote, realizes inventive solutions that turn the very constraints of each project into the design trajectory, exploring opportunistic overlaps between space, program, form, budget, and materials. In many ways, this thesis of their firm's operational strategy is laid out in their 1998 edition of Pamphlet Architecture, Situation Normal, which has become a seminal work of architectural thought in and of itself. Situation Normal's introductory essay, Snafu, is still required reading for many of our students, being discussed at multiple levels, including early design studios, programming, and thesis preparation. Lewis Cermaki Lewis has completed academic, institutional, residential, and hospitality projects throughout the U.S. Their work has been recognized with many publications and awards, including the 2007 National Design Award and multiple AIA Design Awards. The firm was featured in the U.S. Pavilion at the 2004 Venice Architecture Biennale. Their work is in the permanent collections of the Museum of Modern Art, the San Francisco Museum of Modern Art, and the Carnegie Mellon Museum of Art. The principals are co-authors of 4 acclaimed books, most recently Manual of Section, which is also now required reading, and we got to spend a lot of time this afternoon with a fantastic second-year group with Marlene Davis, actually using that text as a teaching tool. It's also currently being exhibited in our reading room gallery just across the atrium. Our speaker tonight, Paul Lewis, FAIA, is a Fellow of the American Academy in Rome, as the winner of the Mercedes T. Bass Rome Prize in Architecture. He is Associate Professor and Associate Dean at Princeton University's School of Architecture. He has also taught at The Ohio State University, Columbia and Barnard Colleges, the Cooper Union, and Parsons School of Design. And I also had the great fortune of having Paul as a thesis advisor along with Guy Nordenson many years ago at Princeton, an experience which absolutely informed my research and professional path in wonderfully constructive ways. So please join me in welcoming our speaker, Paul Lewis.
Everyone hear me? There. Yeah, okay. I could tell when it went on, like people's eyes lit up. Okay, so look, I'm going to talk today about Manual of Section. And this is a book that we worked on for about four, maybe 5 years. And a lot of this book was motivated from both our interest as practitioners in the role of section as a design tool, but also as educators in the relative absence of thinking and scholarship about section, which we felt to be a fundamental drawing instrument, and one that didn't really have a lot of kind of analysis associated with it. On the other hand, you would attend reviews and you'd basically hear crits that would tell a student that says, all right, this is a great section or this is a bad section, and yet there's no real kind of clarity to what that really means. And so we decided that it made sense to actually produce a book that would try to articulate how architects produce section, what different section models or what kind of typology might exist related to section, what kind of effects different types of section have, particularly in the interiors of a building, and how might they be combined in different ways to produce new design opportunities. Part of this, as I said, comes from our own interest in section within our work. We use section a lot to generate the design, and I think it's super important to emphasize that section for us is not something, a cut that you make after you produce the Rhino model. Too often section is done after the design has been done to kind of solve technical issues, and certainly that's one of the real pleasures of section, is that it's the site where questions of structure, of thermal performance, of building materials, of tectonics play out. It's also the site where kind of social hierarchies, organization within the kind of vertical axis of a building are made manifest. And it's that richness that exists within the section that we often use as a design site in itself. Now, one of the interesting things is that not only is a section currently used more often after the fact than generative. But historically, the origins of section as a drawing technique came as a means to describe bodies or buildings that already existed. In other words, section as a drawing technique came about as a means to cut through things that already existed. So it's kind of, its history and its current use is actually kind of interestingly connected, right? So some of the very first section drawings are Leonardo da Vinci's drawings through the skull, or ways in which section was used to try to figure out how monuments of antiquity, here you have the kind of Pantheon, how it was built, right? So one can measure the profile on the outside, one can measure the profile on the inside, and therefore speculate as to what exists within the thickness you can't see. Or in the case of ruins, that were in effect sectioned through nature, one could get a sense of how the building might have been played out tectonically through the role of that level of erosion. So we're kind of interested in the way in which section's been used historically and how it's used in contemporary practices, and trying to find a way that we could write a manual that would actually change it into a more generative technique, not a kind of reactive techniques. One of the interesting ways of looking at Palladio is to see how much the section is really a secondary design tool, right? The plan is the generator. The plan is the key drawing, and in fact then the elevation is the kind of next important information, and the section is almost the kind of scaffolding on which the architecture is then played out. It's the realm of the builder, it's the technical realm, but it's not actually the generative realm. What we find very interesting is to start to think about section not as a kind of backdrop to an elevation, but actually combining section with perspective. And this is the drawing technique that we used extensively within the book. And what it allows you to do is combine two drawing types that are fundamentally at odds with each other, which is really interesting. Because on the one hand, you get the section, which is an abstract cut through something. It's measurable, it's dimension, it can be dimensioned. It actually shows you things you can't see. It's a slice through the invisible. And on the other hand, the perspective then positions you into a kind of condition of experience. You can now inhabit the project, if you will. So you get this kind of really interesting friction between the abstraction of the cut and the immersion or the kind of sensibility or the optical aesthetics of the perspective, and they exist simultaneously. And there's a long history of section perspectives that we see ourselves continuing. It's often a way of kind of playing off, again, the kind of tectonics, the stacking against the kind of experiential. And we've used this in our own drawings, our own design work, not simply as a representational tool, but really as a kind of way of thinking through the logic of a project. So with the book, what we work through is, and what we argue is that there are really 7 different ways in which architects produce effects of section within buildings. These are not, how do I put this? These are not important in and of themselves. In other words, a building that exhibits nest is not in and of itself exhibiting a good section. These are just 7 distinctly different ways in which architects produce effects internal to the building. And of course, hybrids is the most important one, right? The way in which those 7 get recombined in different ways. So I'm going to use this organization to, as a way to kind of frame not only the presentation of the logic of section as played out in the book, but also then give examples of work from our office in where certain models or different types of section have played a kind of significant role within those projects themselves. Okay. Each of these projects that were drawn for the book were existing buildings. There are 63 of them. This is kind of scale comparison between all of those. And for the book, we made sure that, or we wanted to make sure that every single one of the buildings that we were drawing had at some point been built. Most of them still exist. A couple have been demolished, but they all existed. And part of the argument there is we wanted to develop a kind of visual scholarship, a kind of a sense that these would actually be as accurate as possible because we knew we could not only get access to photographs, but also try to get access to working drawings so that the section drawings we would produce would be themselves held to a level of precision that one might hold any other kind of form of scholarship. And again, the argument was that often architectural history is written through text. We wanted to, in a sense, develop a kind of an architectural history through the visual imagery, through section drawings themselves. Okay, so each of the drawings within the book are a single cross-section perspective, and the thinking here was that this would be an analytical book, but not one based on producing multiple diagrams, but just a single drawing, a single cross-section perspective that would fill an entire page, that would then show the kind of wealth of attributes and complexity that for us makes architecture exciting. That in fact too often analytical work in architecture tends to kill the pleasure of architecture, which for us is the complexity of everything occurring simultaneously. Okay, so extrusion. Extrusion is the dumbest form of section, and it's probably when you get a crit as a student and people say your section's terrible, it's probably because all you did is extrude the plan up to the height necessary for the program, call it a day. So this is not really a seductive way of making the vertical dimension of a building. But it tends to define most buildings, most projects, and if it's extended in particular ways, it can actually have interesting qualities. So a couple of examples I'll show is the Glass House by Philip Johnson. It's basically an extruded section. The ceiling floats basically the height necessary for the domestic program inside. But Johnson then intensified this reading by putting so much pressure on the glass, the reflectivity, the relationship between the site, the kind of exchange between interior and exterior, a kind of reduction of anything that would kind of compromise the clarity of that extruded plan. So in a sense, he embraces the limits of the extruded section and turns it into a project in and of itself. Another way you can look at a more interesting extruded section is to start to go to extreme scales. So a good example is Nervi's Palace of Labor. This thing is 80 feet high. It's much higher than necessary for the kind of functioning of the program, and it turns it into a space of spectacle. It also celebrates the structural kind of logic behind the project, which is a series of mushrooms, structural mushrooms, concrete columns that then span out to a series of steel umbrellas that are then gapped by a series of glass skylights that then register the autonomy of each of these columns. A kind of fantastic project. Again, the section is nothing more than an excessive version of an extruded section. Okay. So the first project I'll present from the office is a school for 200 young children. It's a kind of early childhood education. And we're going to break ground on this on Thursday, so I'm super excited about this project. It's in Arkansas. And one of the problems of this project, or one of the limits really, is that not only was the site super flat, had almost no section to it, but we also knew that the program of the involving young children would basically mean that stairs were not really a possibility. It had to be a single floor. It's a very tight budget, and so we started to work through the possibilities within the ceiling and knew that we were going to be working largely with bar joists connected to two load-bearing walls. And then in effect, most of our operations would take place in plan. So in a sense, the entire project, and it's ironic to have a lecture about section of the first project I'm presenting is largely about plan, but that's okay. That here the argument was that we would have these double-loaded corridor classrooms that would spiral off of a collective center. Inside each of the classrooms would be a kind of house for the kids that would then be marked on the entry hallway, forming a kind of domestic framing, and then also registered on the exterior porch screening. This would be an acoustic kind of material that would give a kind of sense of place within a place, a room within a room, that would give a little bit of variety to the extruded section. The center of the building was super crucial because it had to be the kind of collective zone, and probably even more importantly was that we wanted to embrace the landscape into the heart of the project so that the playscapes were actually the point of gathering for the line of classrooms, and that this would then engage the exterior activity into the internal life of the building itself. And at the front entry, the battens that were actually registering the height of the building. So in fact, we were emphatic about this extruded height is now playing out across the landscape. So we didn't just have 6-foot-high fences. These were 20-foot-high fence posts that would become the identity of building, and they would start to migrate from battens out into the front of the building, kind of marking the entry, a kind of crowd gathering, if you will, that would kind of form the kind of logic as you work your way into the building. And again, the kind of central heart was imagined as a kind of a dysfunctional panopticon, if you will. There's no center in this thing. There's multiple centroids or multiple points of passage. So there'd be no single control point, but yet there'd still be the efficiency and the organizational logic that comes from centralized plans. And more importantly than that center, would get used as a collective gathering space, not only for gross motor rooms for the children, but also could be expanded out to become a collective area for the community for about 200 to 300 people to gather in the heart of the building. Okay. So a number of the projects that we do in New York City are in existing spaces that are often built for certain degrees of efficiency. They're extruded sections. And so what do we do in those contexts? So show you just 2 restaurant projects that we did where we started to develop a kind of split personality. We'd know that the plan would have to be incredibly efficient or have to work really well, have to maximize seating, flow, et cetera. And a lot of then our interest and kind of design focus would be placed on the surfaces, the walls and the ceilings within the project. So in this particular bakery, we started to stack about 3 miles of felt and stained plywood, 3/4 inch thick, that would then aggregate to produce the entire surface of the space. And it would have kind of interesting different consequences where it would have the appearance of velocity in elevation, or I should say in perspective. And then when you move to elevation, it would start to flatten out. Here, the speaker marks the difference between the wall and the ceiling, and the padded surface would change from being darker, where it was used really as the back of the banquettes, to then becoming lighter as you migrated up to the sky. And then seen from the street, the architecture of this extruded section became the signage, right? This was the thing that would draw you in. We've likened this to the moment of jumping into hyperspace, that kind of sensibility of velocity. Unfortunately, the food wasn't very good, and it was expensive, and so the place closed in a year. But we still enjoyed the kind of pleasure of trying to take this kind of relatively banal space and turning it into something much more euphoric. A similar project, but probably one of the smallest projects that we did, another restaurant project in New York, for a hot dog stand. The client, by the time we laid out the kitchen, that's how big it is. You can see that's the bathroom, not ADA approved at all. But a tiny space, and we imagined that it would really be just a way to formalize the activity of lining up, picking your hot dog, buying it, eating it, and leaving. And so here's the basic diagram of the project. And the thought was, and what we told the client, is that we're actually going to do something counterintuitive. We're going to raise the floor by 6 inches, and we're going to drop the ceiling by about 1.5 to 2 feet. And this is going to give you the benefit of going from a space that looks like this to something that through a forced perspective will actually appear to be bigger. And the consequence is that your hot dog is going to look larger as a result. And that's the kind of thing you have to use to sell a client on something that seems to make a space smaller. So here's a view into the hot dog stand. And for us, it was important that initial spatial logic then gets played out in the materials. So if you look closely, you realize that the steel up front is about 6 inch wide, and as it goes back, it becomes 2 inch wide planks, increasing or making legible that forced perspective in the materials. And then the gap between every other piece of steel then becomes backlit as a dotted line, registering the difference between anticipation and consumption. Because the floor is sloped and the cantilever bamboo counter, which actually cantilevers from outside into the space, is flat, it means that everybody can find a comfortable place in which to eat their hot dog. Okay, so stack. Stack is the second model, and it doesn't take a rocket scientist to figure out what stack is. Basically, it's extruded sections placed on top of each other. It's Again, not inherently interesting from an architectural standpoint. It's in some ways the model of section that a lot of operations in section are trying to get away from. In other words, a lot of what we talk about in the book is the difficulty of introducing complexity in the vertical axis of a building when you're trying to push back against the efficiencies of contemporary construction. The concrete frame, the steel frame, Chicago frame, the relentlessness by which this can reproduce real estate now means that when an architect tries to do something in section, they're often having to justify what they do because they're taking away a certain amount of square footage. With stack is basically the model that you're often trying to fight against. But it still can have certain interesting qualities. What do I mean by that? So one model of stack is to start to look at how you can introduce difference from floor to floor. So if you look at Mises' well-known Crown Hall, a fantastic building, it's primarily known by the main kind of drafting hall or the main level. But that level is only possible because there's the lower level. So in a sense, the stacking of a service served, all of the kind of support spaces are largely in the lower level. That's what enables the possibility of the grandeur of the upper floor. And that service served diagram of the stack section is something that Kahn exploited repetitively, and certainly one of his best known versions is the Salk Institute, where the laboratory floors were given a certain degree of freedom because of the scale of the service floors or the service plenums that existed above them. So the building is basically a kind of stacking of two different sets of floor plates on top of each other. Now, you can start looking at Lino Bobardi's museum and say, in effect, this is a stacked section that's now been elevated. It's now still maintaining the efficiency, if you will, of two different floor plates placed on top of each other, but now being displaced above the ground, allowing the urban sidewalk or the urban or urbanity in general to be able to migrate into the main floor of the building. It's also fascinating because it tends to be known for these dramatic kind of spanning very, very large-scale beams. But again, it's the areas underground that are actually enabling the possibility of a museum to exist with this iconic image. One of the best-known projects, thanks to Rem Koolhaas's book, Delirious New York, the best-known projects that looks at differences within the stack section is the Downtown Athletic Club. And for those of you who don't know, what makes this building fascinating is that within a relatively tight urban footprint, an athletic club could then deploy a particular program, one per floor. So one floor would be built to the height necessary for, say, squash courts, another one for the height of a mini golf course, another one for a swimming pool, and so forth. So every floor to floor was unique because it was mapped to the program because the footprint of the urban site was relatively small. And it's that difference that gets played out that's kind of fascinating. And it's also only really revealed by moving into an elevator from floor to floor. An anecdote is that I live right here on the card-playing billiard floor. It was converted into a condo building in about 2004. And let's just say that there are all kinds of anomalies in the building because turning this section into a kind of generic condo didn't always work. There are some units where you go in and there's some nice kitchen areas. You descend down into what should be bedrooms and you realize there are no windows and you're probably in what used to be the swimming pool. The facade is landmarked, so you couldn't add new windows. And even my apartment, you have to go up a ramp that goes up 2 feet so that you can actually then look out the windows, because when it was card playing and billiard floor, the windows were set very high, so you wouldn't be distracted by looking out the window while you're engaged in those leisure activities. So we have 2 feet of vacant space underneath our apartment that I want to turn into a conversation pit, but that hasn't happened yet, so because we're just renting. So, okay, an extreme version of the stack section, looking at variation, difference on each floor, is the MVRDV's Hanover Pavilion, significantly inspired by OMA's work, which they're a descendant of, where here not only do you have different floor to floor, different program, but different structural system, different environments, different microclimates that are all taking different aspects of the Dutch landscape and starting to place it on top of each other for the logic of an international expo. Okay, so with the project that we did looking at suburbia, we were trying to imagine how section could be used to introduce a means to mitigate some of the excesses of horizontal sprawl, in a sense to continue the American dream, but played out with the role of section as instrumental to the landscape. What this meant is that we would take the large areas of the big box stores and actually place McMansions on top of these areas. In a sense, kind of migrating the residential development onto the roofs of the commercial development. Now, what was crucial about this for us is that these things were going to be maintained independent from each other. They would, in other words, there would be a certain kind of what we called satirical efficiencies between these two levels, so that you could actually have, say, grass being kept green year-round. You could use the sprinkler system for the fire suppression in the big box store that would then water the lawn. You would use the structure of the kind of shelving units of the big box store to set up the cadence of the residential neighborhood. But you wouldn't actually be able to go from one to the other without commuting around the block. In other words, both of these areas would maintain their autonomy from each other. They would simply develop a kind of codependence through their position and section. In other words, they would maintain their separation through the stacked section, and then that commute around the block would then allow you to develop a parking garage with a playing field in the middle of it that would replace the endless surface parking adjacent to a lot of big box stores that exist now. So this was a way of thinking through the stacked section and the benefits and how that might start to inform a kind of larger suburban landscape. In a project that was a little less speculative and one dealing with some very pressing and prescient problems, we had looked at the areas of the Back Bay of New Jersey that probably should have never had houses built on them in the first place. These areas that from Google Earth look like diseases, these strange kind of, and they almost look like things that you're looking into a petri dish. These are these kind of vacation finger canals that have been built on wetlands. Highly susceptible to flooding, really areas that are very difficult, and in certain cases, particularly the back area of Atlantic City, this is Atlantic City, and we were looking specifically at these lower income neighborhoods in the Back Bay, this area called Chelsea Heights. The question was, how do you develop a strategy that avoids the problem of either fortification, which is the seawall model that says, okay, you can protect them with a seawall, but it has all kinds of problems, not the least of which is it's expensive, it cuts off the neighborhood from the water, it produces the illusion of safety, and as we learned from Katrina, the ability for catastrophic failure when these are overtopped, and it also doesn't allow water, as we witnessed in Houston, to actually migrate out. The other model is retreat, which is basically say they should have never been built on, they should just disappear, which is also difficult because the community often that you're telling to retreat doesn't really like that, and you lose your tax base, and it's a difficult model. So we've been looking at how one could develop an amphibious suburb, and where this ties into this lecture is this is largely done through section. This is arguing that the suburban house, when rethought through the vertical axis, could develop a different relationship with the landscape, with a rethinking of what the lawn would be. And it's already happening, right? This is already at play. The way in which if you go through areas that are susceptible to flooding, houses are being lifted up, they're being built on stilts, and properties are being sold with these stilts already built onto them as if you anticipate that as part of the landscape. So they're incredible kind of taxonomy. This is another whole lecture, but the problem of what happens when you disconnect the building from the ground, where do you put the front door, for example? Is it the underbelly? What do you do with that underbelly? And there's some really interesting ways in which people have kind of in an ad hoc way solved this. This is the surrogate lawn where the deck becomes as big as a lawn, but it produces an even darker area underneath. Anyways, the point of this is that we started looking at, if you start to look at elevating not just houses, but roadways, of infrastructure, and started to kind of take seriously what would happen if this occurred much more instrumentally at a larger scale over a longer period of time. How might this be a way to argue for a form of resilience? So this is Chelsea Heights, and under Hurricane Sandy, it was inundated with water, very serious damage across the way. And we would argue that the first move would be to actually develop an evacuation corridor that would be a porous kind of flood wall. It would allow water to come in. It would allow wetlands to migrate into the excessive alleyways. Alleyways would get converted back to canals so you could start flushing the neighborhood again. That this, combined with, over time, elevation of houses, could start to transform the neighborhood much more back into a wetland that has a series of residences that exist through the role of the stack section. And then that means that when there is the storm surge, which will happen, it's not catastrophic. It occurs, it's just part of the way of embracing existence on this landscape. So we, also as a product of Hurricane Sandy, we've been looking at, we got hired to redesign Steeplechase Pier, which is this over 3 football field long pier at the end of Coney Island. Was damaged in Hurricane Sandy. And it's extraordinarily thin and extraordinarily long and just kind of floats above the beach and the water. It's kind of a great section. It's it's this incredibly thin stack section. And so a lot of our operation, knowing that we had to deal with crowds of people moving on it, had to be much more minimal through the role of subtle variations to the floor, using benches to position people in different way. These are the kind of push you, pull me benches. You can look out to the water. You can look to people watching. And so if you are with somebody who has a different opinion as to what they want to look at, you can both kind of sit there, be next to each other and looking in opposite directions. And even a kind of collective chase that would allow people to sunbathe as a group. Other subtle moments within this super long surface were developed as a kind of sunshade device that would then cast the shadows, the letters of Coney Island on the surface of the boardwalk. And my favorite moment is at the end of the pier, just slightly lifting that pier up, the surface of the pier up, so that people walking out to the end of the pier can coexist with the fishermen who tend to fill up the end of the pier. And then at the kind of culmination of this long walk, you can then turn around and look back to Coney Island itself. So again, through subtle operations, given the kind of position and section that this thing already existed in. Okay. So shape is a way of making consequences in section by kind of contouring the ceiling, contouring the floor, or both. And often this is done for reasons of organizing groups of people. It's a way of puddling program, if you will. And when it's in the ceiling, it's often connected with structural forces. So if you look at Felix Candelia's thin shell concrete work, the shape of the ceiling is on the one hand a result of the kind of engineering efficiencies and the flow of forces, but probably more importantly, it helps organize a restaurant that's actually quite large into a series of bays that then have connection back out to the park beyond. So it both defines the structure, but it also articulates the organization of the program. That's done in the ceiling. So if one looks at Utsen's church, one could say that he's using the ceiling to not only evoke notions of clouds, of the heavens, the indirect light floating down, but it's also used to choreograph a relationship between the minister and the congregation. So there's a specific social program being played out, as well as the kind of aesthetic qualities related to that program. This is very different than, for example, Ronchamp, where the convex nature of that underbelly ceiling actually has a tendency to squeeze out to the outside, to kind of push, not only kind of give a sense that there's a space internal, but there's the connection back out to the kind of landscape beyond. What's kind of amazing about drawing this in section is you start to realize that everything that appears to be super thick is actually incredibly thin. This wall and the ceiling are often assumed to be solid concrete. They're not. They're just gunite sprayed on. And the thickest wall is actually the wall that many people think is the thinnest, right? So the tectonics and appearance are often revealed to be anything but truthful when you start looking at it in the specifics of the section. And with Perron and Virilio's church, we included this in the book because not only did they adjust or shape the ceiling, but they also shaped the floor, and in a way that's counterintuitive relative to the traditions of Western architecture. In other words, or I should say Western religious architecture. Here you enter the congregation dead center in the middle. The leader, the minister, is actually almost equal height as the people in the back row. There's a very unusual relationship of hierarchies that are completely played out and made manifest in the way in which the section is deployed. Okay, and probably the most extreme version of a shaped section that's been built is Ito's Opera House that was just completed a couple of years ago, maybe 2 years ago. And you start to see the limits of the shaped section, which is to say that there's only one moment where you can really walk on a shaped section. And not surprisingly, in order for this building to really function, it has to then be kind of intersected with a whole series of stacked sections, right? That's where most of the program takes place. And what I find fascinating is the degree to which this diagram of this continuously connected curvature is constantly being presented as the diagram for the project, yet the experience or what's revealed through this section is in some ways the limits of how that can be used as an occupiable space. Okay. So for a museum competition that we did a number of years ago, we were interested in how you could develop an entire project just by adjusting the floor and just by adjusting the ceiling. So just taking the landscape or the ground and the ceiling and starting to kind of move them into each other. And the reason for doing that was to, in a sense, start to kind of critique the conventional museum space. That if this is the section of the conventional museum space, it tends to stage a fairly static relationship between the museum goer, the art, and the space itself. And we were interested in how you could start to introduce not only difference, but a difference that then could be played out in a whole different range of programmatic opportunities. Relationships between inside and outside could be much more complex. You could get links between different programs, between different expectations of structure, between details and large surfaces, between walls and ceilings. And so here, just in an example, a way in which the kind of photovoltaic covered ceiling would drop down and become the vitrine that would then extend outside, capture an outside space inside the project. There were, I think, about 1,200 entries to this competition. So we knew that we had to have a diagram that would be convincing and easy to understand. But we didn't win the project, and instead we decided to build the diagram in Las Vegas in an all-you-can-eat buffet, which is where a lot of what we think are good ideas often go to find their realization in a slightly watered-down version. Anyway, so this is an all-you-can-eat buffet for 600 people. It's very large, and so the argument, similar to Candella's use of the roof, was to try to break down the scale while still providing connections, and that was to be done by contouring the ceiling and the floor. In this particular diagram, synthetic with each other, so we get adjustments in the acoustic ceiling that would map to the adjustments in the banquettes. That would then produce these kind of clusters or different rooms that would still allow you to, when you stood up, you'd actually then be able to look out to the garden or the kind of pool beyond, and probably more importantly for the client, you'd be able to look and see all of the serving areas of the buffet around the periphery. So we would get a sense of intimacy while at the same time the expanse and the kind of excesses of Las Vegas buffets played out. The the RCP for us is often where we spend more time than we do the plan. The reflected ceiling plan is an underutilized drawing kind of site, if you will. So here you can see how we're developing not only these contoured bands of acoustic material, but also starting to kind of develop kind of grains of lights that would gather as a kind of cross grain against those ribbons, and those would be realized with either a series of hi-hats when it goes through the material, or actually drop down into glass discs where there was moments of gap between the two different rhythms. So, okay, and a final, actually second to last shape section that we've done was in a project in Claremont, California, and this was a maintenance building that we're converting into an open office for administrators from across the collective universities. And so we had an interesting challenge in that we were working with a building that not only had associations with being a maintenance building, it was a kind of pre-manufactured, pre-engineered steel structure. It had existed for 10 years, and we were kind of repurposing it as an open office. But so we ended up working with a space that looks like this. Now, on the one hand, it came with certain problems, aesthetically and so forth, but it also came with this, effectively column-free space that's almost a football field long and 100 feet wide, with 35-foot-high ceilings, which if you were going to propose a ground-up single-story building, you probably couldn't get away with that scale of space, that relative few number of columns. It meant that almost all of our mechanical systems were going to go in the ceiling, and that a lot of our work, again, was in the reflected ceiling plan. And we developed not only kind of a spacing of solitubes to bring natural light in, but then would start to kind of cover this with a kind of topography or a ceiling cloud of acoustic baffles that would then allow the light to come in through and between those baffles, but would then form a collective surface, giving identity and coherence to the project, giving a kind of shape section that would both reference the existing building, but also give it a new functionality. Specifically, that allowed us to have sunlight seem to almost cast and move through the ceiling during the course of the day, and then shift from natural light to artificial light as it went from day to night. In the middle of this space, we developed a kind of bleacher to nowhere, in part because this was an electrical transformer that we couldn't move underneath here. So we're like, okay, we'll just put a gathering space up. I kind of like the idea you could start walking and you couldn't keep going, you turn around. But it actually works as a nice collector in the heart of the space. On the outside of the building, our thought was to try to play with the relatively banal gabled geometry of the pre-engineered building and to kind of use it against itself. So we would take those geometries and start to extend them beyond the limits of the building, and to start to capture outside spaces, courtyards, gathering places that would in effect thicken the skin of the building, but not by adding new geometry, but simply attenuating the shape section that was already inherent in the building. And even at the front of the building, being able to start to peel that skin away from the building, forming a kind of a hand inviting people into the heart of this maintenance building, now turned into a collective open office. Okay. This is a project we just finished a couple of weeks ago, and it's in a McKim Mead & White building at Columbia University, and it's an interesting case where the number of mechanical systems that have been added to neoclassical buildings have really changed how they're perceived and how they can be developed. So our challenge here was to make an auditorium for where the Pritzker Prize is given out. It's the main auditorium for the Columbia's School of Journalism. And on the other hand, we had all of this existing mechanical equipment we had to work with that had just been added to the space, filled up the space. So our hope was to make a kind of a development of section, a way of articulating the ceiling that would engage and kind of hide all this stuff, but also allow view out to the windows from the space itself, to try to maintain some of the integrity of the McKimmey and White neoclassicism. So this was done through a kind of sequence of different coffered ceilings, what we called innie-outies. They could be adjusted to be mechanical diffusers or lights or projectors. And so that we would get a kind of coherent ceiling that would deal with the diversity of all this stuff, and then still provide a kind of an underbelly that would give a kind of coherence aesthetically to the space as well. And some views of it looking towards the stage as the ceiling opens up, and then just some details of the acoustic surface of this ceiling. So again, I think that ceilings are, for me, as important, if not more important than floors in developing the architectural character of a project. Okay. So shear is a kind of super, well, I think that all these section types are really fascinating. Some are less fascinating than others, but this shear is basically a way in which you can keep the exact same amount of square footage, but start to introduce variation by simply offsetting or shearing that floor plate as you either move vertically or horizontally. So it operates either as a horizontal shear or as a vertical shear. So what do I mean by that? So a horizontal shear is basically where from floor plate to floor plate you start to kind of rake or push the floor plates to the side. And what it allows you to do is open up one side of the building to more light and air, useful for terraces and other kind of aspects of the program that need greater access to those amenities. It has the opposite effect that on the other side you get a kind of darker area, a kind of an underbelly. And so what Sauvage did, which was quite brilliant in his housing project, is use the horizontal shear against itself, kind of back to back, and therefore the underbelly was then filled in with a swimming hall, so that this program that requires less light than the terraces now fills in that and solves that problem of the underbelly. Another example of the horizontal shear is Biggs and Plott's or mountain housing project. And what's interesting, and it should be noted about this, is that it was it's a parking garage first and a housing project that was laid over top of a parking garage. In other words, the amount of parking here is much more than you need to just inhabit these apartments. And that's why this extreme rake was possible, which gave the ability to have almost as much exterior terrace as indoor terrace. So one can almost kind of calibrate the effect of the horizontal shear based on the amount of incline that you use, and that's going to determine not only how much exposure you have to the sky, but also the underbelly that then has to often be filled with some other kind of program. Okay. Weissman and Frady took the horizontal shear and played it on top of itself, right? So what that gave you then is a series of double height spaces working their way through the heart of the building so that you can be up in this collective gathering point, being able to look all the way through the building out to the campus of Barnard College beyond. And in a similar way, at the Netherlands Institute for Sound and Vision, the horizontal shear was played at 90 degrees, both carving up from the ground to a skylight and also stacking down with a series of ziggurats that allow you to access the archive down below. And that gives now a kind of collective space as a result of the horizontal shear. Okay, so vertical shear does something quite different. Where the horizontal shear tends to benefit the sides, the kind of periphery of the building as you move the floor plates, vertical shear operates internally, and it does it through offsetting floor to floor. It's the split level argument, right? So with Hertzberger's school, these floors are all placed relatively at split levels or half levels to each other. That then allows there to be a more social program inside. The vertical shear usually intensifies the amount of visual and acoustic exchange within a building, but you don't lose any square footage of your floor plate, technically. What Hertzberger does really intelligently is he also then pulls parts of the classroom program back away from this area so that they maintain a little bit more privacy from the more intense social area in the heart of the building. Diller, Scofidio, and Renfro did something a little bit different within the Brown Creative Arts Institute. And here, the vertical shear is actually registered by a series of glass walls that maintain acoustic separation, but also then allow the different program spaces to have extreme proximity to each other, right? So you can have a performance hall, a corridor for walking through the campus, adjacent to a meeting area, adjacent to a performance space, next to a dance, and these had the capacity to have that much greater visual connection with each other, or if needed, one could pull a curtain and start to separate them out. The important thing here is that there is no, in plan, there's no appearance of lost square footage, right? And yet there's an intensification through the vertical axis of the program's connection to each other. And a much smaller project, an apartment for a private client, which had a split level possibility. We lodged a staircase right in the split level and used the staircase that became a kind of screen as a kind of separation between more public programs, the living room, from a kind of more private kind of area, a TV room or a den, and that became the kind of heart of the project, is accentuating that vertical shear within the apartment. Okay. So as I said, these section types are not complicated. This is, I have a suspicion most of you know what this section type is. It's a hole, right? It's a hole in the ground, right? A hole in the floor. Architects use this all the time, sometimes even without kind of wanting them. You know, mechanical shaftways, elevators and so forth are technically holes that enable things to occur within the vertical axis by cutting and removing a portion of the floor plate. And that's the key component here, right? Is that a hole basically argues that you're taking away a certain amount of the floor plate, and therefore you have to justify it through what it enables. So one can look at the double height spaces, say in Corbusier's apartment building, or a small house, I should say, in Stuttgart, as a way of kind of benefiting and defining the public program, the living area, and distinguishing it from the bedrooms or the more private area, but more importantly then allowing light and the kind of grandeur or the kind of hierarchical difference between these two to be legible within the project. So effectively this is a hole in a kind of very specific architectural way that has consequences, but has to be justified by the removal of that amount of square footage. Frank Lloyd Wright's Larkin building, in a sense, is a hole that now becomes a space, becomes the heart of the project, right? So atriums are very, very large holes that define a project. And in a sense, this project is better known through its atrium than its exterior. It's both used as a kind of social center, an identity, a kind of mechanical system, a way of bringing light in. It's the organizing principle. It's the logic of the project, right? And atriums, as you know very well by this building, are fantastic ways to kind of coordinate social groups of people, to start to give life internal to the building, but they do come with a certain degree of loss, right? The Ford Foundation is a fantastic atrium that really, combined with a little bit of horizontal shear, allows a kind of garden to grow in the heart of Manhattan and start to grow up through a building. It's very much built as a refuge from the city in which it was built. You know, this was meant to be in contrast to New York City of the late 1960s, right? A bit of reserve, a bit of protection, a heterotopia, if you will. And an extreme version of that, in John Portman's hand, becomes the spectacle atrium of these hotels, with the flying glass elevators sliding up and down, moving vertiginously. What's fascinating here is the degree to which horizontal shear is used to kind of stage gathering places, which are as frequently positioned to look inside the building as they are to Times Square outside, which is kind of amazing. You put a hotel on Times Square and most of your restaurants don't look at Times Square, they look inside. It tells you a lot about the thinking about the city when this thing was designed. So, okay. Holes don't have to be singular, they can be morcellated, they can be spread across. So Ito's MediaTek is a brilliant combination of a structural column with a hole, right? Two things that might actually appear to be opposites. One's the removal of structure, the other is the structural integrity of the vertical axis. Here they're combined together, so you get these mesh columns that actually migrate through a series of holes, enabling both connection, structural connection, as well as circulation through the building, as well as mechanical systems, and they become the entire architectural logic of the project. It's a fantastic project, in part because it simply takes a totally different approach to the thinking about what structure and whole could be rethought or hybridized toward new inventive ends. Okay, in a much more subtle way, less budget, we did a project for Gallaudet University. It's the University for the Deaf, where we wanted to place a staircase in the middle of the project, but really see this as a staircase that would be a point of communication literally. When most of the communication is done through sign language, visual connection is hyper crucial, and so we positioned the stairs being much smaller than the hole it existed in, so that one could actually maintain conversation while not only being on the stair, but also to the lounges that then kind of exfoliated beyond the staircase itself. So that, in effect, just simply making the space for the stair slightly larger then allowed these connections to kind of be possible within the center of the building. And on the lower level, we really developed the ground floor as a kind of shaped section or kind of staggered section where these individual seating areas could allow for more focused conversations, but the whole thing could operate as a kind of an auditorium for presentations. And again, the visual connections that were necessary for sign language were crucial throughout the project. This was similarly, in part because a lot of your vertical cuts through buildings have to be justified for pragmatic reasons. With this art museum in Austin, Texas, we spent a lot of time not only kind of looking at the history of the building, which had been a theater and then got turned into a department store. As a result, it acquired a whole new floor that separated this proscenium space into two levels. A lot of our work was spent developing vertical circulation that then would actually enrich the building, particularly through stairs and elevators. So, for example, we wanted to make sure that the stair that would get you from the ground floor up to the main gallery would be a kind of, not just a kind of an efficient kind of generic stair, but would take on a life of its own. It would be both super heavy, meaning the bottom 3 treads would be cast in concrete, and the upper 21 would be suspended down from the roof deck, made from the same material as the roof deck, linking their way through the heart of the building. Each of these things were extremely heavy, about 30 feet long in some cases, and they had to actually be put into the building before the building was even closed up. So we're getting the finished stair, millwork being put in before the building was even done. Caused a lot of stress on the part of the contractor, just dealing with kind of locking these things in. But what we liked very much about this is that the overall geometry, the incline of both the sides of the stair and the kind of rake towards the front were all set in motion by the slope of the nosing, right? So that minor detail now started to be extended into the overall geometry, and it meant that we could have square holes that could be cut through both floor plates that would be used to structurally hang these things, but that would produce a stair that would be 5 feet wide at the bottom and expand out to be 8 feet at the top, in a sense opening up as you move your way from the lower level up into the gallery space beyond. We also looked at ways that we could move artwork from floor to floor without losing square footage by having a very large freight elevator. So this was a way of kind of burying a scissor lift that can move a crate up, and then have it descend back down and essentially disappear. And my favorite moment is when the floor up above just collapses and then you return back to being a gallery. So again, how holes could appear and disappear depending on their use within the building. We were able to work on this building in 2 phases. And in the first phase, we had developed this roof deck, which turned out to be one of the more popular spaces in the building. The problem is that it was susceptible to weather, right? It's Austin, Texas, hot sun, unpredictable rain. And so we were asked in the second phase to actually think about ways to make this more, ways to control the weather, to provide shade, provide some degree of weather protection. So for us, this was an opportunity to really kind of look at that extruded section, but to do it at a very high level, meaning, I should say, displace the extrusion up to a high level. So this was a knife edge perforated aluminum roof that was then positioned at 23 feet above the roof deck. It formed the backdrop for an artwork by the artist Jim Hodges with Liberty and Justice for All. Those are 8-foot high letters, but we wanted this roof canopy to appear to be almost like it was floating away. And again, the knife edge coming down to that 2-inch knife edge appearing to be almost kind of without weight, without mass. And that it would change from day to night and be a backdrop for activities on Congress Avenue. It has a fantastic prominent location within the city. To provide protection against the weather, we looked at ways that we could have a kind of curtain system that would allow you to pull a kind of diaphanous screen, a weather protection around the building relatively quickly. So you could transform this space from being truly outdoors to having some degree of protection, but also get a kind of almost like kind of gossamer sensibility, right? This is really tall, and then when it's covered, it starts to become, it almost have the appearance of being somewhat either underwater or somehow in the clouds, and yet be able to retract those curtains and feel like you're really part of the city, engaged in the city. You're both indoors and outdoors simultaneously, and it's been very effective along those lines as a very unusual space to be a way to exist within the city and be inside the building simultaneously. Okay, so incline. Incline, we could have called this ramp, is really a way in which architects have tried to push your plan through the section to another plan, right? So to maintain continuity of a plan and be able to get from one level to the other. It seems pretty straightforward, but it comes with a particular problem, and that is that for every continuity in plan or portion of the plan that's continuous from one level to another, you get an incredible amount of discontinuity in that very plan. So what do I mean by that? So if you look at Villa Savoye, yeah, you may get, say, 3 feet of continuity along the ramp, but you get about 33 feet of discontinuity because of the sides of the ramp, right? So this is one of the real challenges of the incline. Is how do you both get the benefit but also deal with the problems? And it's interesting to see the way in which different architects have dealt with that. So what does Frank Lloyd Wright do? In the Guggenheim, he basically makes the entire project into a ramp and gets rid of the discontinuity by sticking an atrium where there should be discontinuity, right? So here it's all continuous surface, and where there may be problems from side to side, it's now opened up, turned into a spectacle, right? So fantastic mating of 2 different section types. One can question whether it's a great museum given the continuously inclined floor, but that's another discussion, and that's where you need curators and other people. From a section standpoint, it's fantastic, right? That's why it's on the cover of the book. Anyway, so not all architects want to absolve the incline for its problems of discontinuity. And we argue that actually in the Kunsthal and Rem Koolhaas OMA's art center in Rotterdam, that in fact they intensified the discontinuity, that the entire project is about placing 2 programs on 2 different sides of those ramps in extreme proximity and skewering them and then making those have as much friction as possible next to each other, even to the point that the entry into the building side swipes are used to when it was first open, side swipes the auditorium. You actually enter into a floor plate that's immediately adjacent to the auditorium. You have to descend down through the auditorium to get to the coat room, to get to the first level of galleries. And you're constantly spiraling along and rubbing up against this discontinuity as the heart of the project. Okay, so we, like many designers, have been kind of fascinated over the years with the continuous surface, with the incline, and so here we're looking at ways that you could actually develop a project that would be based on the possibilities of electric cars. Namely, you don't have toxic emissions, therefore you should be able to do different things in buildings with cars. And so this was a way of arguing that you could actually take the suburban desire of parking with extreme proximity to program and play out that suburban desire within an urban footprint. In other words, to make a drive-up skyscraper, a skyscraper that would go up about 35 stories, intertwining program and parking into the entire thing. Being able to stack program where the programs that require the most amount of parking would be on the lower level, retail, and as you work your way up through the project from hotel to an office building and finally residential at the top. And continuously slicing through the ramps would be an express ramp that would allow you to kind of shortcut the continuous looping of the parking garage that gets you up through the rest of the building. What this allowed us to do is then imagine that you could take in the retail area, for example, the strip mall and start to wrap it around itself. Every parking space is a good parking space. It has close proximity to program. And more importantly, the act of getting from your car to the retail is now not across a windswept parking lot, but actually into a collective social atrium that allows you to start to have greater connection with other humans as you do this banal activity of going from your car to the big box store. The hotel level had a similar combination where we wanted to mix the lowbrow motel with the Portman Atrium Hotel so that you could park like a motel immediately next to your hotel room or your room, but collectively these would wrap around the spectacle atrium, complete with the express ramp flying through the middle, and then even the possibility that you could actually dive off of the parking garage to get into the swimming pool. So these notions that details matter and that can be sites for specific invention. And then the upper level residential, allowing one to park immediately on top of your unit, descend down in, producing a new vertically organized neighborhood as opposed to the horizontal sprawl of suburbia. Okay. So Nest is the seventh section type, and it differs fundamentally from the other section type in that here the basic unit is not a floor plate, but actually a volume of space. And that these volumes of space can be placed inside of each other, could be intersected, but the key component is the idea that space is thought of as a volume, and that volume is then deployed in a particular way, which is different than the other section types, which largely think about floor plates as individual units. It's a subtle distinction, but I think it's fundamental to how we think through this. So, by way of example, a good nested section, almost like diagrammatically euphoric, is Fujimoto's House N, where you get 3 nested volumes. The inner volume kind of marks the kind of more focused domestic activity of the dining room and the living room. Then it's surrounded by a volume that marks the distinction between interior and exterior. And then added on top of that is actually another volume that is at the outer limits of the property. So one start to get this kind of exchange between all of these different areas through the nested section. In a slightly more subtle way, maybe, Charles Moore takes a very small house and through the kind of positioning of skylights and these kind of eticules is able to kind of increase or turn into a kind of place of a performance, the act of eating and the act of bathing. And again, the key thing here was the way in which these skylights were embedded into the 2x framing system of this really small house. In a much more expensive project and a more complex project, if you will, is Herzog & de Meuron's Prada building in Tokyo, where the more private activities of, say, changing room are now embedded into the floor in these tubes. And then these tubes are actually extended from wall to wall, exterior wall to exterior wall, picking up the diagrid and, more importantly, providing cross bracing or structural stability while also providing those nested interior programs. Oftentimes, the nested program is done for environmental benefits, as well as what I just mentioned being structural or spatial or programmatic. So Beinecke Library, not surprisingly, positions a glass box which has a series of, holds the rare books in a temperate, humidity-controlled environment conducive for the rare books, that's then placed inside the kind of glowing stone skin that then is positioned on the campus. And again, this is another project where you look at how much stuff is below ground that enables the kind of icon of the nested building to float onto Yale's campus. And one of my favorite nested projects is the training center by Jorda, where two really pretty banal buildings, pretty cheap buildings, are placed inside a much larger shed, a totally passive shed with photovoltaic skin that allows for a temperature gradient that would mitigate the extreme temperatures outside before they get to the need for conditioning on the inside here. So in other words, if it's, say, 30 degrees outside, just through passive forces, you've got, say, 50 degrees here, that then the delta between that and the amount of heat necessary to condition the climatic controlled areas is significantly less. But it also produces this fantastic interstitial space, right? It's not inside, it's not outside, it's somewhere in between because of the way in which the nested section is played out. We've worked with nested section in housing projects. This is a project, dormitory, where we wanted to have each study hall be connected to a cantilever study nook that would then be positioned within the collective exterior entry court. So like a kind of theater, one would have your own theater box, and from there you could witness the comings and goings, the daily activity of campus, while also being able to look across to other halls, see what's going on within the dorm itself. With a project in Telluride, which we just won a competition early this summer. This is one of those competitions where it's like we know even before we start designing that we're going to do a nested section. It came with the building came with a set of a perimeter wall already in position. It's a historic, one of the older buildings in town, even though it only goes back to 1920. It exists as a shell, and it's been used as this kind of interesting kind of exterior embedded in the interior already. So we knew that from our earliest sketches that we were going to be positioning the art center as a volume within a volume. It was going to be nested within these walls, and then the project would be about the exchange between the new piece that would be added in and the historic shell. And more importantly, this gave us not only the interesting play between interior and exterior and the ambiguity between those, but it also gave us the benefit of the thermal performance, the humidity control, because we knew that if we had a humidity control on this porous block, it would kill the reading of the block, right? You'd have to basically cover over that historic block. So we let the block be porous and then produce the temperature and humidity controls internal to that, and then gain the benefit of that interstitial space. That interior volume was then also seen as an opportunity for a kind of material difference. So if the stone walls were the perimeter and those would rest on a new concrete foundation, we would develop a timber figure largely built out of cross-laminated timber that would then have an exchange through the use of a series of sliding walls and skylights connecting this timber figure to the stone walls. So from the outside, largely the building is just what it is. It's the historic wall with glimpses of what exists on the inside, but when you pass into the outside, if you will, one then gets a view of the new building that's been added in that activates this space, that can transform, that can adjust from day to night, deal with dark sky initiative, while also dealing with different weather conditions in Telluride, Colorado. The building itself that figure is carved to, in a sense, frame the stone. So even the double height space is meant to make legible the historic walls from the inside. And the key component to the entire project is then the stair that rides up between these two spaces that allows you to descend down into a kind of screening room in the basement. And here you're on a kind of concrete portion of the wall, similar to the museum in Texas. We like this idea that a stair isn't one material but starts to transform as you move up and down it. So the timber figure is still legible in the basement, kind of resting in the basement. And then as you move up the stair, it opens up, becomes a series of steel structures that are weaved into the wood cladding of the new volume, and ultimately opening up to a skylight with the raking of the sun down the surface of the stone walls. The main exhibition space is on that second level, and the perimeter of this room is contoured in a way to kind of frame views and connections to the existing windows on the outside walls, not necessarily for making perfect alignments. In fact, if anything, we actually like the fact that there would be a discrepancy between the new apertures and the historic apertures, so we can get these kind of offsets that would kind of play up and, again, intensify the reading of these two different surfaces. And even the idea of when you would move up and down the elevator, you'd have a window that would look up through the gap between these two materials and these two volumes. As the stair extends up to the roof deck, it actually carves through the wood, and then opens up to really what's the selling point of this project, which is the views. I mean, amazing views of the mountains, both in winter and in summer. And I think in some ways this was, the idea that we would just let the rooftop not be, not block the view of the mountain as much as possible, make it available. This idea of nesting we kind of took to the level that we'd actually make the crate for shipping it based on that argument as well. So the project could fold back up and then be nested in its own protective shell for shipping on American Airlines. So, okay. As I said before, the important thing really is the hybrid, right? How do architects combine these things? And so I'll go through this quickly, because part of the important thing here is now start to take these apart, to realize that the sauna project is really a kind of an extruded section that's been shaped and then animated with holes. In effect, you could say that this is basically a series of stacked shapes, which is actually contradictory if you think about it, and that's one of the challenges and the intrigue of this project is how do you stack shapes and still make them legible, or even stack shapes that are then kind of torqued around to produce an atrium and kind of nested into each other in particular ways. And even Paul Rudolph can be seen as kind of an excessive version of architectural pleasure. It's not surprising that architecture schools are often the sites of incredible section experiments. And again, I think this school is a good example of that. That I think architects are obsessed with section and they get the ability to play it out in architecture schools. Or in the case of Seattle Library, the public library, which is a kind of tour de force of section within the interior of that building. Okay. Very quickly, a recent project where we kind of became obsessed with doing everything in section possible, maybe to the detriment of the project. It became a little too much. A student center that on the one hand had a series of classrooms and offices that we split open and then started to allow the landscape and the paths and the kind of circulation of the campus to come into this collective area between these two bars, and then that would be activated through a series of inclines, shears, ramps, starting to look at kind of ways that you can have meeting areas that are stacked and linked off of a kind of staircase, a kind of excess of possible ways that people could meet and interact with each other in different ways through rethinking the vertical development of this campus center. And on the outside, the building would appear a little bit more normal on the more public faces, facing the heart of the campus, and then would open up towards the more unusual atrium away from the heart of campus. Okay, so very quickly, just a couple of notes, because we've gotten this question occasionally, is how did you do these drawings? How did this happen? Like, where did these drawings come from? Couple of comments. These were all developed in Rhino and then edited in Illustrator. There's no computer software that generates these stuff. It just takes hours and hours. So each of these drawings was roughly somewhere between 140 and 200 hours. To do this, we would actually, as I said, we tried to take this on as a kind of visual scholarship. So not only would we would access photographs, as much as possible we would get in contact with the architects. This is Buckminster Fuller's partner, Mr. Sadao, and we got access to the working drawings to try to be as precise as possible. We would not only model the exterior but also the interior, and then we would spend a long time trying to figure out where the cutting plane would be and where the horizon line that would, in a single view, would make the project as legible as possible, as well as making the section as visible as possible. Here the cutting plane is not through the center, which is normally how you would cut a section through a dome. We moved it slightly in front because it actually allowed, through the perspective, the project to read better. And as I said, we would model, in this case, we modeled the interior expo as it was when it first opened. And then also tried to model the context as precisely as possible. I can tell you it's inherently flawed. It's an impossible exercise because we don't know what Montreal really looked like from this exact view at this particular time, but we did as well as we could within the limits that we had. Redlining drawings of other people's work is really weird, but we had to try to get a level of precision to this multiple stages of red line, working through line weights and to try to get a coherence among all these drawings, in part because we had a range of people who worked over the 4 years on the project. These were, unpaid interns were used in this, which is important to note. As a result, I don't recommend these kind of books as a business venture. It was a labor of love, I think is probably the best way to. And once you're in, we thought it would be a year exercise and we'd get it done, and it just took longer and longer and longer. But anyways, it's been a pleasure, and we had the opportunity at the opening of the book a way to keep our kids busy. We printed out a couple of sheets, said, maybe this would make a great coloring book. And it does produce, this is Henri Sauvage's Blue Period. And Herzog and de Meuron's Psychedelic, that's my daughter, so I'm very proud of that one. And inspiring the next generation of kids to think about section. So there is a manual section coloring book. Not pimping anything here, I'm just saying. So, which did allow us to at least present a handful of these and make them available for your own color interpretation. So. But for us, I think the important thing was that the book is out there. It was designed all to be black and white so that it could sell for around $21 on Amazon so that people can actually buy it. So we're very pleased that it's in its 4th printing, and I was super thrilled to see it upstairs in the studio. So thank you very much.
If anyone would like to ask any questions?
Yeah.
So I realized that when I'm presenting work, I use the word drawing pretty much interchangeably for anything. Is that the same for you when you're talking about section? Do you use section when you're talking about work and say, this section is actually this section?
Yeah, I mean, look, I think that section is a type of drawing, right? If we're with your, the interesting distinction is often between the static print of a drawing and the more manipulatable model, right? That's where things get really interesting, right? But it's often to the detriment of the static print, right? Too often people say, oh, because it exists as a three-dimensional model, I'll just keep spinning it around, and the three-dimensional model is the important thing. The two-dimensional print, the drawing as it was conventionally known, is actually a subset or a substandard version. It's just an output, a moment within the 3D model. And I think that's a mistake, which is to say that one of the real pleasures of the two-dimensional cut, and it could be a plan, it could be a section, but it doesn't show everything at the same time, right? You're only dealing with that one cut. And if you take that on as a design opportunity, it actually gives you a great degree of freedom, right? You don't have to design everything when you're working in a two-dimensional cut. You have to design what's in that cut. And that should actually release you from the burden of having to model the whole damn thing. So, so I don't argue one is better than the other. I do argue they're different and they have different benefits. And too often the two-dimensional, the drawing is losing, it not being used as effectively as it could. And particularly the section we see kind of fading from agency, or it comes in too much as a technical issue and not actually a design issue. And so I think that was one of the things we wanted to foreground with the book. But yeah.
Thanks, Paul. That was a really amazing look at your work. I wonder if you could talk for just a bit about your commitment to drawing in the practice, and maybe what it cost you and what it gets you back.
It's a good question. And I can answer on a number of different levels and I won't. I could talk for. I don't want to do that. I talk way too long. But let me just see if I can give a couple of examples. We still draw a lot, and and on the one hand, sketching is a heck of a lot faster than modeling, right? It doesn't have the precision, but there's a speed associated with sketching by hand. So we still in the office do a lot of sketching. And it's a way of doing iterative work that at some level can be faster. But I think using these things simultaneously for us has always been important, right? So, going between computational, digital modeling, its benefits, and then the ability to like hand draw, sketch, as well as work with CAD and Revit for different purposes. I will say that one of the things that we actually really enjoy is the way in which thinking through a project based on notations of lines as opposed to atmospheric effects of rendering changes, I think, how we think about, say, detailing, for example. So for example, how a line moves from the nose of a stair up the wall of something, for us influences how you were thinking about the edge of that material, right? And the Claremont project, we realized at the end of it, and that was some of the kind of cloud-like ceiling, is actually everything in there is actually a series of lines, whether it's the ceilings, whether it's the dug fir post, whether it's the handrails. The entire project is nothing but lines. And I think that comes out of a real interest in the accumulation of lines as a way of making architecture, as opposed to effects of surfaces. And that I think is, we need to explore it more, but I would argue that's one of the ways in which drawing's not just a kind of technical tool, but actually biases the way which we think about how architecture is developed. So, in a very literal sense. So. There's another question, yeah.
Out of all the sections in the book, is there any one in particular that you found challenging to develop?
It's funny, I got this question about 2 hours ago, so they all had their own problems, but look, the ones that are bigger were harder to do because we both had to get access to more detail and were able to show less detail. So in a weird way, the houses were easier technically to draw, but then we actually then had to figure out all the layers, right? And sometimes, for example, there's a Schindler house in there that we have limited access to. I don't think it exists anymore. But I think that probably some of the projects resisted being revealed well through a single section perspective. So, which is a different kind of challenge, right? I think we made some mistakes, right? I don't think we drew the Kunsthal in the right orientation. I think we should have drawn it in the other cross section. The Buckminster Fuller was very hard to show that very, very thin material in a way that registered once you printed it at this scale, right? So line weight issues became challenging. But I think, look, each of these projects became different in different ways. I would say that the projects that we had the biggest problem with, we didn't include in the book. And an example I gave earlier was there's some building that don't translate very well into a single section. FOA's Yokohama terminal is actually really quite banal in a single section. You need the iterative section. You need multiple. You need the animation of section. So I think the nature of the book and the way in which the book was done as a single drawing then became a kind of limit that then pushed aside certain approaches to section, which is itself probably another essay. But yeah, it's an interesting question. So yeah.
Thanks. Super cool. I'm interested in the political dimension of the book. And so it's like an interesting, so what I wrote in my notes is like, why this book now? And I'm interested in your thoughts on that, because I think about there's the obvious context of 3D modeling and parametric, and you addressed that early on by kind of distinguishing cutting a section versus generating one. But do you think the book is a kind of attempt to grab an aspect of the discipline that's perishing or growing more and more obsolete, or do you think the book is, how is it a manual would be also another way to ask
Yeah. No, look, I think it's a good question, and I think what we were trying to do is at some level acknowledge the difficulty of doing things in the vertical axis, particularly given the pressures of money and capitalism and the way in which the role of section is kind of pushed to the side, or you have to fight for it for other reasons. And so what the hope here was also to try to find a way that we could argue that these are the ways in which section has been done in order to allow for greater invention that builds upon this. So it was in that sense, our argument was it was a manual because it started to kind of break apart, here are basic ways that things are done. Don't repeat these, but actually build upon them and invent new. So I think that one of the difficulties of the book is that it's a book, and that it limited, as I said before, certain ways of thinking about section in a more animated way. And I think that, but again, I think to a certain degree, one could argue that this is our own self-critique is this is a manual section of 21st or 20th century architecture, and does that matter? And probably, because in a sense, this is, all the buildings here only, they're after the invention of the domino, after the Chicago frame, after the dominance of that repetitive construction, right? Very few of these buildings are actually load-bearing arches, so we were trying to say, all right, this is the way in which most buildings are built. How do we as architects operate? So, but it's not, I wouldn't say it's necessarily a manual for cutting-edge roles in section, right? It's not, so that in itself starts to be, I think our own critique of the book was, did it hit a certain limit in order to be a manual in its particular era, in the kind of constraints of contemporary construction practice? So I don't know if I answered your question. I probably revealed more anxiety than I probably should have, but anyways. Yeah. All right. Well, thank you very much. Pleasure. Good.